All right, now we're going to talk about conjugate pairs. So a plus radical b and a minus radical b are called conjugates. And they're conjugates because when we multiply them together, when we multiply a plus radical b and a minus radical b, they will cause the middle terms to go away, and we end up just with a squared minus b. So a conjugate is nice when we have a problem like 4 over 3 plus radical 2. Because the radical 2 is in the denominator, and we're not allowed to leave a radical in the denominator. So how do you get rid of the radical in the denominator? Well, we're used to multiplying by 1 in the form of radical 2 over radical 2, but that won't work here. If we multiply by 1 in the form of radical 2 over radical 2, we'll still have a radical in the denominator, because when you have that binomial 3 plus radical 2 and you multiply it by another radical, you just still have a radical. So the only reason or only way we can get rid of that radical 2 in the denominator is by multiplying by the conjugate pair. So we multiply that 3 plus radical 2 by 3 minus radical 2. And when we do that, that's going to give us a 3 times 3. That's going to give us a 3 times 3 is 9, a radical 2 times a negative radical 2 of a minus 2. So the middle term is going to go away because 3 times negative radical 2 and 3 times positive radical 2 will add up to 0. And that's the magic of that conjugate pair. So when we multiply the numerator, we're going to get 4 times 3 is 12. And then we multiply 4 times negative radical 2, that's 4. That's negative 4 radical 2. So there's a 1 out in front of that radical 2, the understood 1. So we multiply that 4 times that understood 1, and the radical just stays in there. Again, in the denominator, the reason we chose 3 minus radical 2, the conjugate pair, is because it gets rid of the radicals. In the denominator, we just get 9 minus 2, which is, of course, 7. Our final answer ends up being 12 minus 4 radical 2 in the numerator and 7 in the denominator. Now, how do I know that that's simplified? Well, there's no perfect square under the radical, there's no fraction under the radical, and there's no radical in the denominator. So this is simplified.